Hello, Mr. Stone here, helping you with solving single variable equations. For our first example here, we've got x plus 3 equals 8. Now, in order to solve for x, which in this case is our variable, what we want to do is we want to isolate that. We want to get it by itself. In order to do that, in this case, all we need to do is get rid of this 3 that is right there. Then we will have x by itself. Since we are adding 3, we just want to do the opposite operation of addition, which in this case is subtraction. We want to subtract the 3 from the left-hand side of the equation. Now, the equal sign is telling us that what I have on my left is equal to what I have on my right. So if I'm going to subtract on the left, I must do that on the right in order to preserve the equality. If I don't do that, then I can no longer say that this would hold true, that they are equal. So I subtract 3. What we see is that they cancel out there, so I'm left with just x, and I still have equal here. 8 minus 3 is 5. And there I go. I have solved for x right there. X equals 5. You can use just about anything for a variable if you really wanted to. You could even use like a little smiley face, okay, or a drawing of a pretzel, or I don't know, a goldfish. Whatever it is you can use. Most of the time though you will see a single letter, so bye-bye smiley face. Sorry. A minus 4 equals negative 6. Well, think about what I would do here. How would I isolate my variable? I can add 4 because I'm subtracting. That's the opposite. I'm going to add 4 to both sides, again, to preserve the equality. Now these two cancel out, so I just am left with A equals negative 6 plus 4. Think of the number line. Don't get tripped up with your negatives and your positives. If I'm over here at negative 6, positive direction is in the right, the negative is in the left. So I would actually be moving 1, 2, 3, 4 spots to the right, which would give me negative 2. Negative 2 would be my answer. Always think of the number line when you are working with adding positives and negatives. Okay. Multiplication in this case. So I've got 3b equals 24. Again, I want to isolate b. I'm multiplying b by 3. The opposite of multiplication is division. Divide both sides by 3. Now, these two cancel out. So I'm left with b. b is isolated on the left because 3 divided by 3 is 1, and that anything times 1 is equal to itself. So that's where we get the b. 24 divided by 3 is 8. All right, and then again we've solved. B is equal to 8. Our variable was isolated and then solved. X over 9 equals 8. Okay, I'm dividing by 9. And in order to get equality, I need to multiply both sides by 9. So I'm going to do that. I'm going to multiply both sides by 9. And again, these cancel out. We get some equality here. X, because if I multiply by 9, divide by 9, that's 1. Leaves us just with x. I'm undoing the division by 9. 8 times 9 is 72. There we go, another one solved. I want to draw your attention to a special case here, where if you have 6 over x equals 2, the temptation that I see all the time is for people to say, oh, okay, I'm just going to multiply by 6 on both sides, and then I'm going to get, oh, you know, x equals 12. No, 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 don't do this. Don't do this. Don't do this. This doesn't work. That will make you have a big frowny face. Okay? What you want to do, let me do that in green here. What you want to do is if you have 6 over x equals 2, you need to multiply. Always, always, always multiply by the denominator. The denominator is what's in the bottom. So in this case, I want to multiply both sides by x. Alright, if I multiply both sides by x, now over here, I'm left with 2x. These on the left cancel out. Let me do that in blue. These on the left cancel out. So I'm left with 6 equals 2x. Now, this has become a multiplication one, just like we had a few steps ago back up here. So I'm going to divide both sides, excuse me, not by 6. I'm going to divide both sides by 2, divide by 2, cancel. 6 divided by 2 gives me 3. There we go. Again, remember, multiply by what's in the denominator. Don't just multiply by the number that's there. The number is not always the thing you want to multiply by. Whatever is in the denominator is what will clear it up. I want to do one example. Sometimes you're going to have more than one step here. The last one was kind of 2 steps as well. But when we've got a case like this, what I want to do is divide and conquer. I know that I'm going to have to divide by 7 at some point to isolate the a. I also know that I'm going to have to add 2 to clear the left side to isolate a. Now, you have to think kind of backwards as far as order of operations goes, because when you multiply or divide an equation, you multiply or divide the whole side. Okay? If we were to divide by 7 right now, it would actually be all of this stuff over 7. This gets to be a big mess because you cannot divide, you cannot just pull this stuff, the 7 out of those 2. It would not work. It would not be pretty. So when solving equations like this, you need to work kind of backwards of order of operations. So the first thing that I would do is I would add 2 to both sides. So quite often you'll be doing this. Do your addition and subtraction first. Those cancel. I'm left with 7a equal to 21. You've seen this before. Old hat. Divide both sides by 7, yeah. Then I'm left with a equals 21 divided by 7 is 3. There we go. We're set. We're good. Don't forget that when you multiply or divide, you're doing it times the whole side when you are working with equations. And don't forget to multiply by your denominator when you have a variable in the denominator. All the time, really, multiply by the denominator. But don't let that trick you if you see the variable down there. It's all right. All right? Take notes, think about this, bring your questions, continue to be awesome, and everything will be absolutely fabulous. Have a great day.